So the best way to practice some of these things and get an idea of what all this stuff in the regression output means is to practice with some examples. So we're going to look back at our hospital example from earlier, where we wanted to predict the total hospital bill based on the patient's age, their length of stay in the hospital, and the number of days in the ICU. And so here's the Excel file if you don't have the previous one open. And first, we're going to go in and we're going to find and interpret the adjusted coefficient of determination of variation here. And so this is the adjusted R squared, which previously we've only talked about the R squared value, and now we'll look at the adjusted R squared. And then we want to let alpha be 0.1, and we want to test essentially if our model is valid, if we have at least one of our coefficients that's non-zero, and then we'll look at the coefficients individually. So our R squared value is this 0.75166 value. Sometimes we use the adjusted R squared, and there's more detail about this in the textbook if you're interested. But this asked for the adjusted R squared, which essentially means the same thing. So this essentially means that about 73.5-ish percent of the variation in the hospital bills is explained by these three variables: the age of the patient, the number of days in the hospital, and the number of days in the ICU. So there's our R squared. And previously we looked at this coefficients column to come up with our model, and we plugged in some particular X values. Now we want to look to see if our model is valid. So it said to let alpha be 0.1, and we want to test to see if beta 1 and beta 2 and beta 3 all could be 0. Here we have 3 x's, so we will have 3 of these coefficients, or if there's at least one of these betas that's non-zero, so is not equal to 0. And let's see, the test statistic here is an F, and if we look at our output, you might notice this value right here is an F. And you could use f.dist.rt to find the p-value, but the p-value is actually this value labeled significance F. So the p-value for this hypothesis test down here, the p-value is this significance F value. And remember that this e minus 14 means we would move the decimal place 14 to the left. So this is really 0.000 a bunch of times before we get to the 585. And so this p-value is really small, and it's super small, definitely smaller than our alpha. So that means that we'll reject the null hypothesis, and that's good because the null hypothesis was that all of our coefficients were 0. If that was the case, it wouldn't be worth looking at our model anymore. Our model wouldn't really be a valid thing to be looking at. Our x's would be kind of useless for predicting our y. And so we want to reject the null here, and this means that there is enough evidence to conclude that there is a relationship between the amount of the hospital bill and the age of the patient, the number of days in the hospital, and the number of days in the ICU. And so it makes sense to keep talking about this model. But even though we know there's kind of a relationship between all these things, it's still possible that I don't actually need all of these variables in my model. Maybe if I know the patient's age and the number of days they spent in the hospital, maybe I don't need the number of days they spent in the ICU. Maybe that's not super helpful for predicting the bill, or maybe it is. And so what we want to do next is individually test each of our coefficients individually to see if each of them is non-zero or zero. So next, it says, now let's go ahead and let alpha be 0.05, and let's individually test, we'll set up a hypothesis test for beta 1 to see if that's 0 or non-zero. So we'll have this hypothesis test for beta 1, and then we'll have a hypothesis test for beta 2 to see if that's 0 or non-zero. So beta 2 is 0 or non-zero. And then we'll have a hypothesis test for beta 3. So we're doing 3 different hypothesis tests here, one for each of our coefficients individually. And I said that the test statistics for these are going to be t's, and they are in this column labeled t-stat. So the ones that we're going to look at are these ones for age, days in the ICU, days in the hospital, and days in the ICU. So those 3 values are our test statistics. And we could use those test statistics to find the p-values using t.dist, but the p-values are just to the right of the test statistics, so we don't actually need to calculate anything. So this p-value 0.003, that's our p-value for this first hypothesis test. So I'm going to make a little table here where I put the p-values for each of these hypothesis tests. And so this first one has this p-value of 0.003. The beta 2 hypothesis test has the p-value that's 3.7988 e to the minus 5. And then this third one is the p-value for days in the ICU. Okay. And so our alpha here is 0.05. And so this first p-value is less than that alpha, and so is the second one, since that has 4 zeros out front. But the next one, the last one here, is bigger than our alpha. So in these first 2, we'll reject the null hypothesis, and in the last one, we will fail to reject the null. So if we reject the null, that means that we reject that coefficient being 0, and we have enough evidence to conclude that that coefficient is non-zero, which is good. That means that it makes sense to include that variable in our model. So in the first 2, we conclude that those coefficients are non-zero. So that means there's a relationship between the amount of the hospital bill and the age of the patient. So the age of the patient is useful for predicting the hospital bill as long as the other 2 things are still in the model. And that's something that we'll need to worry about and talk more about later. And the beta 2 being non-zero means that we can conclude that the number of days in the hospital is useful for predicting the total hospital bill as long as the other 2 things are in the model. But with beta 3, we failed to reject the null, and so that coefficient could be 0. So that means there's not enough evidence that the number of days in the ICU is useful for predicting the hospital bill as long as we have the other 2 variables still in the model. So really, to see what needs to be included in the model, well, first I need to make sure the overall model is valid and look at the significance F and make sure that that's smaller than my alpha so that not all of my coefficients are 0. But after I do that, then I look at these p-values, and these 2 that are small, that's good. That means those coefficients I want to include in my model, but the one that's a little bit bigger, that means that coefficient could be 0, and so I might not want to include that in my model. And so what we'll do later is we'll do an example like this where we then remove some variables from our model and see what happens once we remove those variables one by one. And now, if we want to make confidence intervals for our 3 regression coefficients, we can look over on the right And you might notice there are two kind of sets of columns that say lower and upper 95%. At the moment, these are exactly the same. If I go back into that data analysis tool and choose regression, to change the confidence level, you can check confidence and change 95% to something different, and that will replace one of the upper and lower columns with whatever confidence level you enter there. And by default, it includes 95% twice. But let's just pick one of these pairs to look at. Let's look at the far right. So if I look over here, this is giving me a confidence interval for each of my coefficients on the variables. So if I look at this row right here, this is telling me that beta 1, I'm 95% confident that beta 1 is between those two values, that beta 1 is between that 39.5 value and this 187.6 value. And then the next line is telling me that I am 95% confident that beta 2 is between 680 and this 1756 value. And then lastly, beta 3 is between these two values here. And what you might notice is these top two confidence intervals do not include 0. And those were the two variables that, or coefficients, that we rejected the null and concluded that they were non-zero using an alpha of 0.05. And those 95% confidence intervals do not include 0. But the last one, the one that we said might be 0, sure enough has 0 in the confidence interval. The lower confidence limit is negative and the upper is positive. And so beta 3 could be 0. And so that's something that we might not want to include in our model as long as we're including the other two variables. And so let's think about what these confidence intervals mean. So if I look at the beta 1 confidence interval, what this means is that we're 95% confident that increasing the age of the patient by 1 year increases the hospital bill anywhere between $39.5 and $187.6. And so changing the age variable by 1 increases the hospital bill by that amount. And you could say something similar about beta 2. Increasing the number of days in the hospital increases the total bill somewhere between about $680 and $1,756. Whereas this last confidence interval is telling us that beta 3, that's telling us if I increase the number of days in the ICU by 1, then there's a range of things that can happen. The hospital bill could decrease by about $95, anywhere from that to it increasing by $4,521. Anything in that range is possible. And zeros in that range, it could not change it. And so that's kind of what these mean and how we would explain the interpretations of these confidence intervals for the coefficients.